So in this video we'll look into what is the heating effect on bicarbonates, oxalates, acetates and formates. So first of all let us look into a general trend by which these particular metal bicarbonates, oxalates, acetates and formates decomposes. So when these compounds are heated, then we get metal carbonate and other product in general. We'll look into what this other product is soon. We have also learned in the previous video that when these metal carbonates are heated, then if these carbonates are not made up of sodium, potassium, rubidium and cesium, then we will get metal oxide and CO2. And also if these metal oxide, the resulting metal oxide upon heating metal carbonate, if this is Ag or Hg oxide, then it will automatically decompose into metal NO2 because these oxides are not stable. Now I was talking about the other product here, so let us look what the other product would be in each case, that is in bicarbonates, oxalates, acetates and formates. So in case of HCO3 minus, I have talked here that upon heating the metal bicarbonates, oxalates, acetates and formates, we will get a metal carbonate. That means we get CO3 2 minus. So basically what we have to do, we have to subtract CO3 minus from each of these compound to get this other product here. So when we subtract CO3 2 minus from HCO3 minus, then we get certain product, and similarly for the other cases. So let us look here what these other products are. So in case of HCO3 minus, we have to subtract CO3 2 minus, but we have only one minus sign here. So we'll have to subtract CO3 2 minus by adding two such HCO3 minus compound. So subtracting CO3 2 minus from 2 HCO3 minus, we get H2CO3, and we know that H2CO3 is unstable and at room temperature it decomposes into H2O and CO2. Next, if we subtract CO3 2 minus from C2O42 minus, then we get carbon monoxide. Next, if we subtract CO3 2 minus, then here also we see that here we have only one minus sign, so we have to add two such compound, and then we'll have to subtract CO3 2 minus from it. So the resulting compound would be CH3COO CH3. Next, in case of HCO minus, also again we'll have to add two such compound because only one minus sign is there. So upon subtracting CO3 2 minus from 2 HCO3 minus, we get HCHO. Okay, now we have some questions. We have to find the decomposition product of NaHCO3. So this belongs to the carbonate. So when it is heated, then we get the sodium carbonate and other product. What would be the other product in case of bicarbonates? We have learned here that it's H2CO3. So here we are H2CO3, and we know that H2CO3 is unstable, so it decomposes at room temperature into H2O plus CO2. So the final product would be Na2CO3 plus H2O plus CO2. Now we know that Na2CO3, this sodium carbonate are stable, so it does not decompose upon heating. Next, Zn(C2O4). Now oxalate of zinc. We have learned that we will definitely get Zn(CO3), that is zinc carbonate. And next, other product. What would be the other product in case of oxalate? We have learned here that it would be carbon monoxide. So we get CO as the other product. And we also know that when Zn(CO3) is heated, then it does not belong to the exception that we have dealt here, these sodium, potassium, rubidium and cesium. So it will again decompose into oxide and CO2. So the final product would be ZnO and CO2 from Zn(CO3) and CO from Zn(C2O4). And we have learned that this ZnO does not belong to Hg or Ag, so it won't further decompose into the metal and oxide. Next, we have to decompose CH3COO followed by Zn. So in this case again we will have carbonate automatically and CH3COO CH3. This is the other product because we are decomposing the acetates here, and again Zn(CO3) will further decompose into ZnO and CO2. So the final product would be ZnO plus CO2 plus CH3COO CH3. Now upon heating HgCO2O4, that is the oxalate of mercury, we get definitely mercury carbonate, and the other product would be carbon monoxide in the case of oxalate. Now upon heating HgCO3, we will get the mercury oxide and the CO2, and upon heating actually at room temperature, HgO decompose into metal and oxygen. Now we are not seeing oxygen in the product. The reason is that the oxygen formed has oxidized the CO that we obtained in the first step into CO2. So the final product would be the metallic residue of mercury and carbon dioxide. Next, we have to decompose the acetate of mercury again, then we'll get mercury carbonate and CH3COO CH3 as the other product. Now HgCO3 would decompose into HgO and CO2, and CH3COO CH3 would come from the first step. Now here again we get O2 from Hg, that is Hg oxide and the metal residue, but we see O2 in the product because we have nothing here to be further oxidized into its maximum oxidation state, so O2 would remain as it is, unlike the previous case. And the next we have to decompose this particular compound, so we will get HgC2CO3, obviously the carbonate, and HCHO. From HgCO3 we again get HgO plus CO2 and HCHO from the first step, and again HgO would be heated, we get Hg plus O2 plus CO2 plus HCOOH. Now HCOOH is the new compound and we don't get O2 as was expected from the decomposition of HgO. So what happens is the O2 that is obtained by the decomposition of HgO is used in oxidizing HCOOH into HCHO into HCOOH. So we want CO2 in the product, instead we see HCHO converted into HCOOH due to the oxidation of HCHO into HCOOH. That's it from this lecture, and in the next video we'll look into some questions on the basis of the concept that we have learned so far in the heating effect in general, and particularly the concept that we have learned in this video itself.